Hello children, I am Bindu. You have already read the laws of chemical combination last part. The laws of chemical combination consists of two laws. One is law of conservation of mass and another one is law of constant proportion. Our today's topic is Dalton's atomic theory from atoms and molecules. Before starting the new lesson, let's revise the previous topic. The total mass of the products formed in a chemical reaction is exactly equal to the mass of the reactants. This is the law of conservation of mass. Law of constant proportion was given by Joseph L. Proust. In a chemical substance, the elements are always present in fixed proportions by mass. This is known as the law of constant proportion. Learning outcomes. At the end of this session, you will be able to understand about reasons of Dalton's atomic theory, postulates of Dalton's atomic theory, keywords, matter, atom, chemical properties, compound. This is the concept map of today's lesson. In our last session, we read laws of chemical combination which were given by Lavoisier and Proust. The next problem faced by scientists was to give appropriate explanation of these laws. By early 19th century, the scientists knew some laws governing chemical reactions, but they could not understand why are these laws valid. Why cannot the elements combine in any arbitrary proportion? The English school teacher John Dalton proposed the basic theory about the nature of matter. In 1808, he presented his atomic theory, which was a turning point in the study of matter. But there were some reasons due to which Dalton gave his proposal. If mass was to be conserved, then all elements must be made up of extremely small particles called atoms. If law of constant proportion is to be followed, the particles of same substance cannot be different. On the basis of these two reasons, Dalton proposed atomic theory, a new system of chemical philosophy. Matter consists of indivisible particles called atoms. Atoms are neither created nor destroyed in a chemical reaction. Reorganization of atoms occur in chemical reactions. All the atoms of a same element have identical mass and identical chemical properties. Atoms of different elements have different masses and different chemical properties. Compounds are formed when atoms of different elements combine in simple whole number ratios. That is, chemical change is the union or separation of atoms as in whole numbers. When atoms of different elements combine in different whole number of ratios, they form different compounds. Example, carbon monoxide, CO. Carbon dioxide, CO2. Hence, C and O combine in 1:1 and 1:2 ratios respectively to give two different compounds. What you have learned? Elements are composed of incredibly small particles called atoms. Atoms of the same element are exactly identical and atoms of different elements are different. Atoms cannot be divided, created or destroyed. Atoms of different elements combine in whole number ratios to form chemical compounds. In chemical reactions, atoms are combined, separated and rearranged.